Hello guys, welcome again. My name is Prabhat Fandekar. So in the previous classes we had discussed about the module 1 and module 2, right? So now we will discussing about module 3, that is a solid propellant rocket. Okay, so first we will see the history. Solid propellant rocket or the solid rocket. It is a rocket with the rocket engine that uses the solid propellant. Okay, so what is meant by propellant? Basically, propellant means a fuel of that. Okay, propellant means a fuel of that. So propellant consists of the fuel also and the oxidizer also, because this is a non-air breathing engines. Okay, so in the air breathing engines only fuel is present in the engine, and oxygen, like engine will take the oxygen from the atmosphere, right? But this is a non-air breathing engines, so non-air breathing engines having their oxidizer part in the engine itself. Got it? The earliest rocket were the solid fuel rockets powdered by the gunpowder. Means at that time, earliest like a 13th century, 14th century at that time. So at that time, the gunpowder was used as a solid fuel. But after many inventions that found the like different oxidizer part, different fuel part, so they were used in the warfare by the Chinese, Persian, Mongols, Indian as early as in the 13th century. All the rockets used some form of solid or the powdered propellant. Right. In the first module, I have discussed that the solid propellant rocket consists of the fuel part and the oxidizer part, and the both is in the form of solid. Right, means the solid fuel, that the solid grain, you can say the solid grain is in the form of solid. Okay, so the raw material is in the form of powdered form. Raw means like there are different materials, we will different materials, different ingredients we will add into the propellant part. Okay, so that we will see it in the next slides. Okay, so until the 20th century, when the liquid propellant rocket offered the more efficient and controllable alternatives. Okay, means until the 20th century, the solid powdered propellant were used. So after inventions, they have found that the liquid propellant rockets are more efficient and controllable alternatives. Controllable means you can control it. Okay, so this is a controllable alternative and more efficient. Means efficiency of the liquid propellant rocket is more as compared to the solid one. And next one is a specific impulse is also high as compared to the solid, right? The solid propellant, the solid rockets are still used in today's industry in the military purpose worldwide. Means mostly in the today's industry, mostly the solid propellant rockets are used in the missiles, long range missiles, short range missiles, and the boosters rocket, models rocket, etc., etc. Okay, because it is very simple and reliable. Okay, next. So okay, so this is one video, so just see the video. This is an animated video, you will get an idea after seeing this video. So we will discuss each and every part by seeing this video. Okay, so this is the outer part. Okay, means this is the outer body of the rocket. Got it? The outer body is mainly made by the aluminium, titanium, etc. because it's the weight of the aluminium is low as compared to the steel and other types of materials, metals. Got it? So you can see the first part is a nose part, right? So what is the use of nose part? Mainly the payload section is consist of like a payload section is present in the nose part. Okay, and the rest of it is the propulsion system. So this is the outer casing, you can see the casing layer. Okay, so insulation layer. In first module, we have discussed about the insulation layer. So what is meant by insulation basically? So insulation is one type of material or chemical is used to insulate from the heat. Means resist the heat, protect the heat. Okay, means in the combustion chamber, the temperature is goes beyond the 3000, 4000 Kelvin, like that. Okay, so and this one like outer casing. So outer casing is basically made from the aluminum, titanium, like that. So it may chances that these types of materials may be affected by the heat. Got it? So for that, insulation must be provided and apply over the propellant part. So it raises the heat transfer to the motor. Okay, so what's this, guys? So this is a nozzle part. So you can see the CD nozzle, converging diverging nozzle, right? So this is basically nozzle part. So what is the function of the nozzle? So nozzle is used to convert the heat or thermal energy into kinetic energy and producing the thrust. Okay, so this is a propellant part. Okay, so in the first slide we have discussed about the propellant. So what is a propellant? It is a mixture of fuel part and the oxidizer part. Okay, so this is a propellant. So you can see, so it looks like a star, right? So there are different types of grain based on their shape and size, like a star grain, like hollow cylindrical grain, then dog bone multi-perforated grain, then like etc etc. So there are different types of grain. So we will see in the next slides. See, so this is a nose part, means payload section. Then this is a igniter. So what is mean by igniter? Basically the igniter producing the electric spark. Okay, so it's used to burn the propellant. So by producing the spark is used to burn the propellant. So this is a propellant. Okay, so now we will see some process, like first one is the oxidizer part, then next is a fuel part. So both, when you add both in one format, like for example, when you make when you want to make a small quantity of propellant, so you have to add that in one small beaker and you have to mix it. Okay, so that is a mixing procedure of that. See, mainly the nitrates, perchlorates, liquid oxygen. So these are the oxidizers. Liquid oxygens are used in the liquid propellant. Okay, and mainly the plastics or resin materials are used as a fuel part. See, you can see this is a mixing procedure. So in the mixing procedure, see, the oxidizer and the fuel is present in it. Okay, so you have to mix it properly. So after mixing, the oxidizer and fuel is tightly bonded. So this is a propellant grain. Propellant consists of oxidizer and fuel part both. So this is now we will see the working principle. So what is the first step? First step is ignite the propellant. See, you can see the spark plug. So because of the spark plug, the combustion process start or ignition started. So that's why. So then flame come from the nozzle and nozzle generate the thrust. So that is a basic mechanism behind it. Got it? See. Okay, great. So I hope you have got the point. Okay. So now just tell me guys, what are the different points indicating? First one. So the first point indicating like that violet color. So this is a propellant grain. Okay. Then second point. The second point is a this part. So this part is situated at the first end. So this is a igniter part, right? And the third one, what is the third part? So third part basically indicating the combustion process. And what about the fourth? This is a nozzle part, and the last one is a exhaust gases. Got it? Okay. So this slide we have already discussed in the first introduction class, right? So first we will revise it once. So we have already seen that video. So in the video also you have seen the igniter part, then the motor casing, then the insulation, propellant grain and the nozzle. So these are basically the main component of the solid rocket engine. Got it? Yes, so we have discussed about the insulation, inhibitor and liner also. That means like these are some chemicals are used to resist the heat. Okay, it's also known as a restrictor. Got it? So liner is like a sticky part. So it's like promote the good bonding between the propellant and the casing. Okay, so it won't be move here and there. So that's why it should be a fixed position. That propellant should be in the fixed position in the motor. So that's why you have to take care of that also. Okay, so this is basically the insulation inhibitor. So we have discussed this. Next one. Then there are four types in the solid propellant. First one is a double base or the homogeneous propellant, then composite or the heterogeneous propellant, and the composite modified double base propellant, and the last one is a nitramine propellant. Okay, so we will see this part and see these types in detail. First one is a double base or homogeneous propeller. Okay, so in the double base and homogeneous propeller, so we can use two types. Two types mean basically the two chemicals. First one is a nitrocellulose. First one is a nitrocellulose and the second one is a nitroglycerine. Okay, so nitrocellulose is a fuel rich. Okay, fuel rich means is acts as a fuel, nitrocellulose. And next one is a nitroglycerine. So nitroglycerine is means oxygen content is present in the nitroglycerine, so that's why it acts as an oxidizer. So it is a oxidizer rich. Understood? So that is a basic two chemicals we are using in the double base or the homogeneous propellant. To ensure that the propellant obtained is a rigid solid, one need to reduce the proportion glycerin nitroglycerin substituently. It means that, see, if you want the propellant nearly solid, okay, it means nearly tends to solid. So in that case you have to add more quantity of nitrocellulose. Okay, more quantity of nitrocellulose because the nitrocellulose is in the form of solid. And if you want the slurry like structure or slurry like propellant, so in that case you have to add the nitroglycerine extra, or extra means the more quantity, means you have to calculate first ratio of it, like oxidizer by fuel ratio, it known as the OBF ratio. I think you have heard about this term, OBF ratio. OBF ratio means amount of oxygen, oxygen means oxidizer, so amount of oxidizer divided by amount of fuel. So in generally, means typically the Ng by Nc means OBF ratio will be 0.8 to 1. 1 means a 50-50 ratio, like a 50% Ng and the 50% Nc. And when you go for the 0.8, 0.8 means numerator is greater than denominator, means Nc part, means the fuel part is greater than the oxidizer part. So it's likely, see here I have wrote that hence the homogeneous solid propellant is always the fuel rich. Got it? So these propellant are also called as a double base propellant. So these types of propellant is used in the short range or the tactical missiles. Got it, guys? So this is the first type. Then second type. Second type is a composite or the heterogeneous propellant. Okay, so composite or heterogeneous propellant also having the oxidizer part and the fuel part. But in the fuel part, there are so many ingredients will be there. Okay, so we will discuss that. So first we will see the oxidizer part. So these are some examples of oxidizer. For example, ammonium perchlorate, ammonium nitrate, potassium nitrate, etc. etc. So these are commonly used oxidizer in the composite solid propellant. Okay, and next one is application. So what is the application of it? Like long range missiles, then the strategic missiles, long vehicles, launch vehicles, etc. So these are some application of it. Okay, so as I have told you that the fuel part is consist of so many ingredients. So these are some ingredients. For example, first one is a binder. So binder plays an important role in the fuel parts, like a major role or important role. So that is a binder. So HTBB, mostly use HTBB, then PBAN, then CTPP. So these are some fuel binders used in the composite solid propellant. Next one is a plasticizer. So plasticizer is used to enhance the performance. Okay, so mostly DOA, DO means dioctyl adipate is used, then DBP is also used, then DOP is also used. Next one is a curing agent. So curing agent is used to harden the propellant. Okay, curing agent is used to hardening the propellant. So for example, TDI. So TDI is mostly used as a curing agent. So that is a toluene diisocyanide. Then IPDI is also used. Next one is a modifier or enhancer. Okay, so there are some modifier or enhancer will be present is to enhance the performance, enhance the burning rate, enhance the burning properties, enhance the performance like that. So ferric oxide or the iron oxide. So this is a most commonly used enhancer. Next one is a metal fuel. So there are so many metals, means metal powder we can use as a energetic particles like aluminium, boron, lithium, etc. etc. These types of material we can use as a energetic particle. Understood? So that is the second part. Then the next part is a composite modified double base propellant. So in the composite modified double base propellant, generally the AP is added to double base propellant for a reducing of fuel richness, which improves the specific impulse. Okay, so if you increase the quantity of space that ammonium perchlorate means the oxidizer part. Okay, is the oxygen quantity in the ammonium perchlorate is high and oxygen is present in the ammonium perchlorate. So if you increase the oxidizer part in the propellant, so it's means like indirectly you can say that like if you increase the oxidizer, so obviously the fuel quantity will be decreases. Got it? So that thus it is a combination of composite and the double base propellant. Okay, so first one we have discussed the double base, second we have discussed the composite. So this is a combination of composite and the double base. Got it? And the last one is a nitramine propellant. So explosives, then HMX, RDX. So RDX is like means you have I think heard about these types of chemicals. So this is the explosive chemicals. So these types of chemicals are mostly used in making explosive materials, bomb, like that things. Okay, so these types of chemicals are also used in the propellant, also used as a propellant. So HMX and RDX are added to the fuel binder compromising of HTBB instead of the AP and cure to form a nitramine propellant. Understood? So these types of HMX and RDX is also used to making a propellant. So that is a nitramine propellant type. Okay. Next one is a propellant grain. Yes, next one is a propellant grain. So yes, so in the video, so when we were discussing about the video, so in that video, I have told you that there are different types of propellant shape and size. First one is a star grain propellant, then wagon wheel grain propellant, then next one is a multi-perforated, so dog bone, dendrite. So these are some types of different types of grain. Got it? So it's based on their shape, like a star. This looks like a star. Dog bone. See, you can see this looks like a dog bone, like that. Okay, so these are the. So basically, so there are different types of manufacturing tools. Manufacturing tools means like mold material will be there for making these types of grain. So there are different mold material will be present for making a different grain design. Got it? Okay, now the different types of grain. So now we are discussing about the thrust and time. Okay, so basically this is the experimental part. Basically, means for example, if you burn these types of grain, you will get these types of graph as their respective grain type. Got it? Means if you burn these types of grain, for example, first one. So if you burn, so this is basically the hollow cylindrical grain. So if you burn this hollow cylindrical grain, you will get the thrust versus time graph like that. Okay. Second one, if you burn these types of grain, you will get a thrust versus time graph like that, etc. etc. Means that only. Got it? So what is it means why we are calculating this like a thrust versus time graph and these types of graphs. What is it? It is used to checking the burning property and the burning type basically. So it indicates the burning type, like a thrust versus time graph indicating the burning type. For example, first one, so you can see, so this is a gradually increases, right? So this is a gradually increases. So this types of graph is known as a progressive burning. Got it? So second one is the same, like it's constant. So this types of graph is known as a neutral burning. Got it? And in the fourth graph, you can see this is a gradually decreases. So this types of graph is indicating the regressive burning. So yes, in the next slide we will discuss same. Just read the part, you will get it. Like yes, so this graph is indicating the progressive, neutral, and regressive. So it means the thrust, pressure, and the burning surface area increases with burning time. Second one, regressive means it decreases with burning time, and neutral, in the neutral part it remains same with the burning time. Got it? So the graph means thrust versus time graph of the propellant, okay, indicating the burning time. Next one. Now we will discuss the making process. So what is making process basically? So making process, it means the making means the like first one is a preparation of slurry, then casting, curing. So this is a process of making any propellant. Okay, process of making any propellant means, for example, wait, I'll show you like this. See, this is a propellant grain, right? So what is the process of making these types of propellant? That we will see in this slide. So there are three major steps. First one is a preparation of slurry. Preparation of slurry. So in the video also we have seen that in the beaker they have just mixed by using the machine, right? So that is a preparation of slurry. This you have to add all the ingredients and the mixed it properly. Got it? Means after adding all the ingredients you will get the slurry types of material. Got it? Because like ST, for example, STBB. So STBB is like a very thick liquid, okay, gel like structure. Then for example AP is ammonium perchlorate, ammonium nitrate. It is a crystalline solids. Okay, I mean some ingredients are in liquid form, some ingredients are in solid form. So you have to just add it in properly and just mix it properly. So that is your first step. Second one is the casting. Okay, so what is a casting basically? Casting means there are two types of casting present. Like first one is a plating and second one is a mold and mandrel. Okay, first one is a plating and second one is a by using mold and mandrel. So mostly the mold and mandrel is used to making the propellant grain. Okay, and second means first one is a plating. So basically the plating of propellant grain is used to checking the burn rate. Got it? So plating means first casting is used to checking the burn rate and second casting is basically it is an actual propellant grain, making an actual propellant grain like this. Is it? Like this. So this is a actual propellant grain. So this propellant is made by cold and the next one, last one is a curing part. So you have to cure that by using the oven. Got it? So you have to keep in the oven for a specific period of time. Understood? So there are the three making process. First one is the preparation of slurry. You have to add all the ingredients and make a slurry. Second one is a casting. So there are two casting process. First one is a plating part. Second one is a mold and mandrel. So mold and mandrel is used to make a actual grain and the plating part is used to make a grain. So that grain is used means that plating is used to calculate the burn time like performance parameters. And last one is a curing. So you have to keep in the oven for a specific period of time. Okay, yes. So yes, I was talking about the mold and mandrel. It looks like this. So this is a mold and this is a mandrel. Got it? So you have to put it into this mold and you have to pour all the propellant slurry over it. Got it? So this is a female and this is a female and this is a male. So it's known as a mandrel. So you have to put inside. Got it? And then you have to pour all your propellant slurry here. And after that, after casting, so this is basically casting process. So after you have to keep this mold and mandrel into oven. So that is your last step, curing step. Yes, so that one is next one. Now propellant grain requirement. So what are the different requirements will be there for making any propellant grain? First one is a motor, rocket motor requirements. Okay, means rocket motor requirements are basically directly like affected to the propellant grain requirement. For example, if the diameter of motor is very large, then the length of it, so these are small parameters are affected, okay, on the propellant grain design. So you have to design these types of grain based on your motor performance, the motor like parameters. Next one is a grain geometry. Grain geometry means there are different we have discussed about the grain geometry, then grain types. Got it? Then next one is a propellant. Propellant means different types of chemicals will be there. So this is also requirement. Then internal cavity volume. Okay, means you have to take care of that cavity also. Like for example, you have to put that mold and mandrel into or plating on the vibrator. So vibrator is mostly used to, what is the use of vibrator basically? So just imagine that when you put any propellant plate on the vibrator, so that will all the small bubbles which present in the propellant, so that will come upside and that will remove it. Okay, means all the small bubble will remove by using the vibrator. Next one is the processing and fabrication. Means all the processing and fabrication. Fabrication means the motor part you have to fabricate that, like according to all the diameters, all the parameters, length, then ID, OD. So you have to take care of that. Must see all these parameters and all these factors are required to making a burn propellant grain. Got it? Next one. So next one is a propellant characteristics. For example, means the desired propellant means the propellant, it should be having the high specific impulse. So if the specific impulse of that propellant, it is a good part, like, okay, so which means the high gas temperature or the low molecular mass. Okay, if the molecular mass will be low, so then the means whole propellants having the low molecular mass, so obviously the weight of all that type is low, so that is a good thing basically. Then the predictable burning rate to fit a grain design and thrust time requirements. Means the grain means the burning rate. So this term, the burning rate, we will discuss in the upcoming slide. So it should be predictable. So you can predict it. Okay. So if it is a predictable, so it is very like useful for any testing. So if you can predict that, so it will be better for you also. Then pressure exponent and the coefficient exponent should be lower. So if it will high, like if the pressure coefficient and the temperature coefficient, it is high, so then it will affect it. Okay, then it will affect all the parameters. So after affecting the parameter, so it will like, it is not the good thing basically. Okay, so it should be a low, so then all the basic parameters will changes. Okay, then adequate physical properties over the entire working range. Okay, means your propellant, it should be adequate physical properties, means you can use these types of propellant in any range, any working range, any particular conditions. Okay, next one is a high density. You should be having a high density. What it high density means? Low volume, right? Density is equal to mass by volume. High density means low volume. So if the volume of that propellant grain is the low, then you have means you can carry more propellant in that motor. Okay, so it is a good thing, you can carry more propellant. Next one, so predictable ignition quality. Ignition quality means stability, or like how it will burn, like that. So it is a predictable. If it is a predictable, then it will be better for that any testings. Then long life, obviously it should be having a long life. Then the low absorption of moisture. Okay, absorption of moisture means hygroscopicity. One property will be there, it's known as a hygroscopicity. It means that a tendency of moisture absorption. So if the propellant absorb the moisture, so that is not a good thing. Okay, so it will affect the burning properties. If the moisture will be there, so it will affect the burning properties, so obviously burn rate will be reduces. Then simple, safe, low cost, low hazardous manufacture. Then guaranteed availability of materials, means all materials. If you want to make any solid propellant, so you have to means like for example, if you want to make a AP propellant, so the AP and HTPP, so the availability of that, it guaranteed. Okay, means it's not having the propellant is, you don't have any like a solid part or the fuel part, oxidizer part, and the availability is not there, so it is very like affected. Then next one is a non-toxic exhaust. Means after combustion, many gas or many types of gas is releases from the combustion chamber, from the nozzle, right? So in that gas, and like for example the HCl gas. So HCl gas is very harmful. It is a toxic gas. So mainly after the combustion of ammonium perchlorate, the HCl types of gases are releases. Okay, so it is harmful to the human being also, so it should not like that. So the low toxic exhaust gases, got it, and not prone to instability, means it should be in the stability, means the stability is high, it should be having a high stability, like that. Okay, now we will discuss a type of igniter. First one is a pyrotechnic igniter. Second one is a pyrogen igniter, electrical igniter, catalytical igniter, then hypergolic igniter. Okay, so in the picture you can see, so this is a pyrotechnic igniter. Okay, so this is the igniter of actual rocket. So you can see, so what is basically the function of the igniter? It to ignite the propellant, right? So now just see the figure. So you can see the red wire. So it is known, it is like connected to the nichrome wire. Means the nichrome wire is present in the igniter part, and the chemicals like shellac, then ferric oxide, so these types of chemicals is present in the in the igniter part. Okay, so after switching on the electricity, the spark will produces, and because of that spark, the propellant, like the propellant which present in the igniter, will burn. Okay, because of the electricity, the propellant or the that chemicals, particular chemicals which present in the igniter, so that will burn. And because of that, see, you can see, so after the burning of that chemicals, so you can see the flame here. Okay, so flame will come from the small holes. Those small holes is present there. So all the chemicals, flame is come from the hole, and because of the flame, the whole propellant will burn. The whole propellant will start to burn. Okay, so these are some basic types of igniters. Next one is a burning rate. So burning rate property is also important. So this is a ballistic property, burning rate. Okay, so what is mean by burning rate? Basically, like for example, if you want to burn something propellant, okay, if you want to burn some propellant, so you have to know about the burning rate property of it. So it is a property of like burn a specific length of strand. Strand means propellant. Okay, burn a specific length of propellant by a specific burn time. So that is your burn rate. The formula of its length of the strand divided by burn time. Okay, means you have to first you know about the length. Length means, see in the figure you can see thermocouple 1, thermocouple 2. So this is basically the length. The length means distance between the thermocouple 1 and thermocouple 2. Got it? And this is a propellant strand. Propellant strand means a some dimensioned propellant. Okay, means some cutted part of that propellant. A little cutted part of that propellant. So burning rate of the solid propellant is one of the most important factors that determine the performance of the rocket. The burning rate of the rocket motor running with the solid propellant is called a flame regression, which occurs with the ignition in the fuel grain perpendicular to the burn surface. So in the like the solid propellant is burned the perpendicular to the burning surface. Means if the burning surface, so this is a burning surface, right? Means the flame is perpendicular to burn, means like this, perpendicularly burn. Okay, so burn rate is an important factor. So this is the formula that length of strand means the distance between the thermocouple 1's thermocouple 2 and divided by burning time. Burning time means the time taken by the propellant to burn. Got it? So that is a burning rate. So this is a propellant burning rate is influenced by some certain factors. Okay, so there are some factors which affect to the burning rate. First one is a combustion chamber pressure. Okay, combustion chamber pressure means if the combustion chamber pressure is very high, so at that time the burn rate is also very high. Okay, at that time the burn rate is also increases. So this factor is also affect the burn rate. Next one is initial temperature of the propellant grade. Means for example, initial temperature means, as I have discussed in the previous slides, if the moisture is absorbed by the propellant, then obviously the temperature of that propellant is low. Okay, so at the low temperature propellant, so the burning rate of that propellant is very low because of the moisture. And if the moisture will not be present and the temperature is also high, so at that time the burn rate is going to be increases. Velocity of the combustion gases flowing parallel to the burning surface. Okay, it means that the gases means mostly the nitrogen gas means nitrogen gas is present, and nitrogen in the environment of the inert gas, the burning rate is tested. Got it? So all this type of gas is randomly moving around the burning surface at that propellant strand. Okay, so velocity of that gases is also affected. Then next one is a motor acceleration or spinning. So there are two conditions basically, if the motor is spinning or if the motor is at the stationary point. So these two conditions is also affected the burning rate. Understood? Okay, last one. So this is a Crawford bomb setup. So what is a Crawford bomb setup? So this types of setup is used to checking the burn rate. So in the this is a schematic diagram. So this schematic, the first one is a DC supply. So DC supply is used to generating a spark plug or generating a electricity. Got it? Then second one is a timer. So basically timer is used to calculate a or measure a burn time. Okay, so this is a chamber, this is a combustion chamber, and this is a propellant grain, means black color indicating the propellant grain. This is a fuse one means timer 1, timer 2. Okay, and the common wire, and next one is a igniter wire. Okay, so this is the arrangement of it. Like there are four arrangement. First one is a fuse 1, fuse 2 means timer 1, timer 2. Then next one is a igniter wire, and last one is a common wire. So common wire means all the wires are connected to the common wire. Igniter wire, also what is the working principle of that? See, first we will see all this remaining part. Then next one is a surge tank, means all the remaining gas is present in the surge tank. And last one is a nitrogen cylinder. Now we will see the working principle. First one, just see, listen careful. First one is a cylinder gas, means the nitrogen gas. Okay, so the nitrogen is come from this nitrogen cylinder, and sorry, then it will goes to the in the combustion chamber basically. Okay, it will go to the combustion chamber. Next one is a all the connections. So first one, you have to fixed a propellant grain, is that propellant strand. First one is a fuse one wire connected. Then second one is a fuse 2 wire connected. Means you have to keep a specific distance between a fuse 1 and fuse 2 wire. And next one is igniter wire. So igniter wire is connected means some like a small distance away from the fuse 1 wire. And the last one is a common. So after switching on the DC supply, the igniter wire is connected to the propellant, so that wire is burned. Okay, and because of the burning, so propellant strand will start to burn. So when propellant strand will start to burn, so then first one is a fuse 1 wire, so fuse 1 wire cuts. So after cutting the fuse 1 wire, timer gets started. Okay, and next one is a fuse 2 wire. The after cutting the fuse 2 wire, the timer gets stopped. Understood? So this is a working principle of that. So after doing all this firing, all this testing, you will get a burn time for burning a specific length of that propellant. So what is the formula now? The distance between the fuse 1 and fuse 2 divided by the burn time. So burn time you will get from the timer. So that is your burn rate. So burn rate is a ballistic property. So you will get from these types of setup. Okay. Yes. So yes guys, so in this module we had discussed about all the solid propellant rockets, how it works, all the mechanism, different types of rocket. I mean solid rocket. Then the grain part we had discussed about the burning process also, burning type also, then making procedure also, then which setup is used for checking the burn time, that is a Crawford bomb setup, right? So we had discussed about the Crawford bomb also. So then the desirable properties, then the igniter part also we had discussed about the igniter part. So we have seen each and every part which related to solid propellant grain or solid propellant engine. Understood? Okay, so I hope you have got all the information correctly. And yes, so this is our third module, and next module we will see the liquid propellant engine. Okay, thank you so much, guys. Bye bye.